What am I going to be talking about today? Yeah. Okay. Okay. Fantastic. Uh, is everybody able to hear me well? Yes. Fantastic. Thank you. Okay. So we're going to be talking about high performance observability. What does that even mean, actually? Yeah. So, and we're going to be talking about observability at the edge. How does that work? And in servers, and for servers, in cloud, in Civo, in AWS, anywhere, or in data center. How does that work? So, first of all, who am I? I'm Prabhat Sharma. I'm founder at OpenObserve. Previously, I was at AWS, working as an architect, and I was working directly with customers. And I met hundreds of customers over a period of 4.5 years when I worked at AWS. And what I found was that there was one persistent problem that almost all the customers faced, which is around observability when they're running their cloud workloads. And there are hundreds of solutions, literally 100+ solutions out there in the market, right from the companies like Splunk, Datadog, even Amazon CloudWatch. Okay, you have got Grafana and whatnot. Now, what I found was that still there was a problem out over there. For logs, almost everybody uses Elasticsearch, at least 95% of the people. And everybody used it and everybody hated it. And I was like, and this was in 2021. And I was thinking like, how do you end up in a world where everybody uses something and everybody hates it? Shouldn't be the case. So I thought, let me try to solve this particular problem. So as a side project, I built something called Zinc Search, which we'll not be talking about today. But that project became popular. A lot of people used it. It was an alternative to Elasticsearch, written in Go. Okay, pretty lightweight. So people loved it. And then I started a company called OpenObserve. And that is exactly what we're going to be talking about today. And why we built it. So first thing about observability. When we talk about observability, we talk about logs, metrics, and traces, plus a couple of more things. We talk about dashboards. For front-end monitoring, there are other things that happen. And you need essentially all of these in order for you to understand what is going on in your system. And that is why you use all of these observability tools. So just a quick question. How many of you use Grafana? Raise your hand. Okay, that's a big population. How about Elasticsearch? Okay, little less number of people. Datadog. Okay, Datadog folks. How many of you hate them? Okay, 2 people at the back. Okay, Elasticsearch people who use it. How about you guys? Use managed services or self-hosted? Managed, yes. Nobody wants to run self-hosted Elasticsearch. You'll die. Yeah. So what we are building at OpenObserve, we're building an open source platform for logs, metrics, traces, dashboards, alert, functions. We'll talk about functions a little bit later. But there are a couple more things that we're building. And all of this in a single binary. You download that, run that on your local machine or on a server, wherever. You get all of these, literally all of these. Okay, and essentially a great UI as well. You don't have to have a separate UI too. The UI comes bundled too. Okay, it's pretty high throughput. You can actually run it on on your local machine. There are people who are running it on Raspberry Pi. Okay, so it's that resource efficient, and there are people who are running it, and we have tested it across ingesting a petabyte of data per day, ingesting on several hundred nodes of a cluster, nodes in a cluster. That works extremely well. We actually run our OpenObserve cloud based on this open source tool. Yeah. Now, one of the biggest challenges that I noticed after talking to a lot of people around specifically observability data was storage costs. Where are you going to store all of the data? And that was a big challenge, because when you're storing logs, for example, your platform team or you essentially are allowed to hold the data only for 10 days or 15 days or maybe a month. Anything longer, you're like, let's delete that data because it costs money. Yeah. And we wanted to reduce that particular cost. So if you compare with Elasticsearch, our storage cost is like 140 times lower. How do we do that? We'll come to that. But 140 times, not 1.4%, 14%, or 140%. It's 140 times, to be clear. We're an open source tool. There are a lot of people using it globally right now, 1,000 plus active installations, right from the startups to Fortune 500 companies, okay, at various scale. And we built it in Rust. This is something that I want to talk about. Now, why did we build it in Rust? So, when we started building OpenObserve, we wrote some sample program essentially for our proof of concept around performance. And what we found was that the same code that we wrote for log search or brute force search, when written in Rust, it was more than 2 times faster. Right there. No changes. Same algorithm. Another thing that we also noticed was that I built Zinc search earlier. And memory, that was in Go. And that was a garbage collected language, which means that you do not really have to worry about the memory. Okay? The memory is managed by the compiler for you, and everything is taken care of. But that comes at a cost. And the cost is that if you want to keep the memory under control, you just can't. It'll happen automatically or it'll not happen. You don't know what to do if it doesn't happen. Yeah. And that's pretty bad if you're building a kind of a database or data store. So OpenObserve is kind of a data store or database, you might call it. Okay. And memory safety. We thought, okay, C++ kind of stuff or C, but then we have heard horror stories around Stack Overflows and whatnot. There are just too many bugs. And what we found was that once you write something that actually works, it keeps working in Rust. That means it's highly productive. It's like you write a program, write unit tests around it, okay, it works. And then you don't have to worry about it. Okay. However, mind that there's a steep learning curve. In order to become productive in Rust, it takes at least around 3 months. We were a Go shop. All of us knew Go. Nobody knew Rust. And we were like, we wrote the POC. POC works fine. But building a system, it requires different level of productivity and skill. And it literally took us around 3 months to become productive. And that is exactly why we currently use Go as well as Rust in our company. So for our cloud system, we actually use Go as the front end. But for the core engine, Rust is the key. That essentially is what gives us performance and memory control, specifically. Now, what we have built is a database. You ingest lots of data. Yeah. We ingest lots of data out here. So what we tested was being able to ingest a petabyte of data per day. A petabyte of data. Okay. And in order for us to do that, while we can ingest data, but there's actually a lot more to data when you ingest it. How do you query it? That's another question. Okay. How do you store it? What is the format? Those things are actually pretty difficult out there. Building a query language is not an easy job. Okay. Can be done, but generally you would want to avoid that. And if I come and tell you that, hey, we created an OpenObserve query language, OQL. You're like, I have to learn one more language? Come on. Not done. So we wanted something that people could use that they already knew. So we wanted to use SQL because almost everybody knows that. And we picked up Rust, and we also found that there was a library called Apache Arrow Data Fusion. How many of you folks have heard of it? Apache Arrow Data Fusion? Nobody. So I'll take a couple minutes to explain that. So think about it. If you want to build a database today, in general, say 10 years ago, what is it that you would have done? You would have created a protocol to accept the data. You would have created a file format in which essentially you store the data. You'll build a query language on top of it. Then essentially all the management around database, you would have done that. Memory management, whatnot. Okay. Now, those things are not easy. They take years and years to build. And if you want to build that, and Oracle essentially did that very, very well. They took quite a good amount of time. They built it. They built a fortune doing that. Then others tried doing that. Many of them did well. Microsoft did well with SQL Server. MySQL was okay. It was a good product, but distributed engine, it did not have a distributed engine. It still does not have. There are other people who are trying to do that. And in our case, we were like, okay, we have to build a database. That is what we wanted to do. Now our problem was that was extremely hard. Had we started building from scratch, it would have taken us 2 to 3 years just to create the engine, the database engine. But the Apache Arrow Data Fusion, it allowed us to build all of this, what I'm talking about, what I showed here, logs, metrics, traces, all the functionality as well, in roughly around a year and a half. Okay. So how did we do that? And what does Apache Arrow Data Fusion offer? So Apache Arrow Data Fusion, in fact, is a Rust library that allows you to store data, all the data in Apache Parquet format. If you know, for those who do not know Apache Parquet format, it's a format to store data in columnar format. And columnar format data is extremely well suited for analytics. If you want to do aggregations, they're going to be extremely, extremely fast. Yeah. Okay. And a lot of log data requires aggregations. Say, for example, you have Nginx or Apache logs, and you want to know that how many of the log entries were essentially 500 error or 200 OK. That is all aggregation. And columnar data is essentially very well suited for that. Yeah. And Data Fusion also, what it allows you to do is that it gives you a SQL support on Parquet files. It actually provides a SQL, not only Parquet, it provides you on Parquet, Avro, the plain JSON files as well, and on CSV. So if you want to build an application today, or kind of a database, you should not be starting from fresh today. Pick up Apache Arrow Data Fusion. Okay, it's a fantastic project. Okay. So that's what we are doing. And it provides excellent performance. So there are quite a bunch of things. Now, what did we do with all of this performance? What is the real world impact? And I mentioned that there are around 1,000 plus active installations globally. There is one company that I want to take an example here. So there is a company called Jidu in China. They are an electric vehicle company. These folks essentially, they were using Jaeger plus Elasticsearch for traces. They were ingesting 1 terabyte of data every day. They were actually producing 10 terabytes of data, but they were doing sampling. Okay. Because their Elasticsearch cluster was not performant enough and was costing them too much. They moved to OpenObserve and they started ingesting all the 10 terabytes of data in less hardware and much lower storage costs. So this is essentially like 10x improvement on the infrastructure front and savings. Literally right there. Okay. Today they're ingesting 100 terabytes per day on OpenObserve. Okay. So this is a real world benefit, and there are many others. There are many others who are experiencing similar benefits. Yeah. So what I would like to show is that a quick demo around this. And after this demo, we can quickly go ahead and jump for Q&A. So let's go here. So what I have here is I have one Kubernetes cluster in Civo Cloud. Okay, it's a single node Kubernetes cluster. Okay, it logged me off. But so I have a single node Kubernetes cluster, nothing fancy, 4 CPU, 8 GB RAM. This is actually more than what we need, but let's keep it. We don't have anything else, no load balancers, nothing out here. And what we are going to do now is install OpenObserve and see what it does. How much time does it take for you to install and get up and running? So we go to the documentation and quick start. We go to the self-hosted installation. And we have to go to Kubernetes manifest. We can create a namespace. I have already created that. We just copy this one command, kubectl apply, single command. Okay. 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 Quite a lot of windows here. Okay. So this one command, and it created two things. It created a stateful set and a service. That's all you need. And you could have run a binary as well, a single binary, download and run it on your local laptop. And I'll show you that thing as well. But now what happened here? So let's take a look. It started creating this particular OpenObserve pod. The single pod, 26 seconds, will let it come up. Should take a couple of seconds. But once it is up and running, there's just one pod that you need. It'll allow you to store and analyze logs, matrix, traces, front-end monitoring with a great UI. Just single binary and single pod. For the folks and those who use observability tools, you all know that how many tools that you generally use in general. Okay, this is taking a little long, but okay. We'll just wait for a minute.
So for the front end, you have the recording and everything?
For front end, yes. We do record sessions if you want. There is real user monitoring for performance of front end. Okay, that too. Okay, there is error capture, something a lot of people use Sentry for. So that also works pretty well. So quite a lot of functionality baked in a single binary or single container. So this is up and running. Fantastic. What we're going to do is that let's take a look at, let's expose this via port forwarding. So by the way, folks, this is a tool that I use. See a terminal emulator called Wisdom. I don't know if you guys have seen this, but this is a fantastic tool. Okay. So k minus OpenObserve get SVC. So we've got this one service running here on port 5080. Let's do a port forwarding of this on a localhost 5080. And your application should be available on localhost 5080. Okay, that is all that you needed. And if you look at, and there's a default password that when we copied this from here, applied, there's a username and password called root@example.com. And the password is complex pass #123. So this is our standard password. So which we use, pretty complex, pretty secure. But okay, this is what the UI that you get. And this is what you got in just a couple of minutes in a single binary. Now, if you want to ingest data, the next thing that you want to do is essentially ingest data. You can ingest data from various sources like Kubernetes, Windows, and you get ready-made commands that are actually run, one-liner or two-liner, and just paste it. And if you're using an existing log forwarder like curl, or not curl, nobody uses curl. This is just an example. But Filebit, Fluentbit, all of these, it has integrations with GCP and AWS. So all those logs can be pushed in here as well. Pretty straightforward. What we'll do is that since we are running in a Kubernetes cluster, we're going to go ahead and start ingesting some data. So I'll just copy this. Okay. I'll just quickly make one minor change here for the name of the service. Okay, which is OpenObserve, and run this. And what it'll do is that it will go ahead and install hotel collector, which is pre-configured. And it does a couple of things. It'll start capturing logs, it'll start capturing metrics, and it can actually auto-instrument your applications that are running in Kubernetes, in a Kubernetes cluster. Okay. So if you take a look here.
Any language?
Not any language. If you see here, there are 5 languages that we support out of the box. For Java, .NET, Node.js, Python, and Go. All of these languages, you have to just add one annotation to your deployment file or to your namespace or a pod, and it'll get auto-instrumented, and you'll start getting all the traces directly. Yeah. So now that, let's take a look, okay, and open Observe Collector. So one pod is up and running. Let's take a look at the data that is coming in. So we have all the data started coming in, all of your logs, okay, and you'll also have metrics coming in. And if you look at the streams, streams is where you'll see all the data coming in. You'll see logs, log streams. There's one log stream. There are metrics. There are no traces right now because we don't have any application, and we have not instrumented anything. But here, and one last item that I want to show you is that dashboards, okay? And we have a couple of these dashboards over here that essentially you can simply go ahead and kind of import. Okay, let's pick up this one, copy, and let's go to dashboards and import a dashboard. And you have, okay, this one does not have any data, but let's say namespace objects, node pods, or namespace pods. Let's use this one. Namespace pods. So you already started getting your CPU utilization, memory, okay, network data from ready-made, everything. And we got all of this up and running in literally a couple of minutes. Imagine doing this with Elasticsearch, Grafana, Prometheus, setting all of those kind of things. So I'll stop here for any Q&A. That is all I had to show for today.